Salam, يعطيكم العافية. So today I'm gonna discuss this certain type of questions, and actually this is the first time that this one came. So this variant is 3 and it came in summer 21. So let's just have a look at this question and just like read it carefully. The question says a mixture of ethanol and methanol is burned in oxygen to produce this volume of carbon dioxide and this volume of water. Complete combustion, as we can see, occurs, and the volumes of both the products are measured at this pressure and this temperature. So as we can see, this temperature is 120, and it indicates that the water here is a gas, since like the water boils at 100 degrees Celsius. So once it's greater than 100, then it's in gaseous state. So we're talking about gases. The question says, what is the molar ratio, ethanol, methanol, and the mixture? Literally speaking, we're going to talk about to calculate the moles of ethanol and methanol and then find the ratio between them. So let's have a look, and I just prepared that to show you the exact steps in this case. So let's start with this one in here. The mixture here of ethanol and methanol, it's combusted completely, and we got these volumes of carbon dioxide in water. We have a pressure and a temperature. So once you were given such information, you have to put in your mind, like we're going to use PV equals nRT, okay, and we're going to find the moles and then find the ratios. But this equation is not simple as we think, because it says that you have a mixture of both ethanol and methanol. They're combusted together in a great amount of oxygen. So first of all, you have to write the two equations of both alcohols each apart. Like you're dealing with ethanol and methanol alone. We have methanol that reacts with oxygen, giving carbon dioxide in water. And actually, I balanced the equation first. And the second equation, we have ethanol with oxygen, the semi-starty, and it's balanced. But you have to put in your mind, both methanol and ethanol were combusted together with oxygen. So if you want to write the overall equation, as we can see, it's written in here. The problem in here, what are the information that you were given? You were given the data, which is about water and carbon dioxide. I mean, the pressures and temperature and volumes. But you don't have any idea about the alcohols like ethanol and methanol. Okay. So look at this. So you can say that you don't know the moles of methanol, okay, but you know the ratio with carbon dioxide. You know the ratio with water in here with the same equation. So suppose that like methanol has a value of X, like number of moles, which is X, you don't know. Okay, we're gonna end up with the mole ratio. Then if this X, then if you look at oxygen in here, it will be 3/2 times X. And for carbon dioxide, I just want to write it in a different color. Let's say this one. Suppose that here you have 1-to-1 ratio, then it's X. For water here, it's multiplied by 2, then it's 2X. Okay. So we're going to use these values like 2X, X, 3/2X, and X in here. And we're going to give another symbol for ethanol, which is, let's say, Y. I'm going to give it Y. So for oxygen here, it will be given like 9/2Y. And for oxygen, it's multiplied by 2, then it's 2Y. This is multiplied by 3, then it's 3Y. So you have two equations. Both equations are in combustion reaction, but you need to write the overall equation. So you can sum, or let's say add these together. X for methanol, Y for ethanol of 3/2X plus 9/2Y. So this is for oxygen. It's multiplied by oxygen. For CO2, you just notice that it's X plus 2Y, X plus 2Y. And the same thing here, you have 2X for water plus 3Y. Okay. Now, you have equations. You have the total number of water, Okay, this is the total number of moles of water, and this is the total number of moles of carbon dioxide. And now let's go again. We are given a data, as you can see, and this data was about the temperature and the pressure volumes. So let's start calculating the number of moles of each one. So let's start with the number of moles of water. As you can see, according to the rule, which is PV equals nRT, we have one pressure and volume, temperature, and R is already constant. And we can calculate the number of moles of carbon dioxide, as you can see, and actually we have it. So this is the number of moles of water, and this is the number of moles of carbon dioxide. And now let's go back again. We just noticed that the total number of water in here is equal to this magnitude, and the number of moles of carbon dioxide is the same magnitude. And we have these answers. So we're gonna establish an equation as we can see, or let's say two equations. So the first equation represents, which is, let's say, 2y, we're gonna start with the first one, which is water. We can say 2x plus 3y, and where is the mole of water in here? This is here. So we can establish the first equation, and we're gonna do the same thing for carbon dioxide. So this is for water, number of moles of water, and this is number of moles of carbon dioxide. And now we can use the solving the equation of two variables, like by substitution process or deletion whatsoever, and then you can calculate the value of y, okay, and the value of x. And put in your mind, we assume that from the beginning, y refers to the number of moles of ethanol, and x refers to the number of moles of methanol, and then we can say y equal y to z. This is ethanol, and this is methanol. We have these numbers, we divide over each other, and then the ratio is 3 to 1. 3 to 1, which is 3 ethanol to 1 methanol. So this is the whole story.